Hello, Integrated Math 1. Welcome to lesson E1-1. Now I know it is E1-1. That's because we're trying out a different curriculum this time around using Envision, thus the E in front. And of course, it's our very first unit in the Envision, so it's E1-1. So to kick it off, if you have the textbook available, that's awesome. We're on page 5 to get things started. If you don't, of course, I have everything on my screen as well. So just to kick things off, I just want you to just start thinking a little bit, little model, little discussion. Joshua is going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50 for a kayak rental. You can see over here we have kayak rentals and our rental rates, where a single kayak is $15 per hour. A single sea kayak is $18 per hour. And of course, if you want to double up with a buddy, a double kayak is $25 per hour. So how can Joshua determine the number of hours he can rent a kayak for himself? Go ahead and think about two different options. Hit pause, jot down some thoughts there. So if he's going by himself, we do have two different options, right? We can do 50 divided by 15 just for a single kayak to see what he could do, or 50 divided by 18 if he wants to use a sea kayak. Joshua found out that there's a $25 non-refundable equipment fee in addition to the hourly rates. So there's the hourly rates, but it turns out he has to pay $25 for an equipment fee on top of that. So how does this requirement change the mathematics of the situation? Hit pause, jot down your thoughts, hit play. So this definitely changes things because I have to subtract that 25 out of my $50 before I can even look at my rates, right? So that means he actually doesn't have $50 for an hourly rate. He's only got $25 to spend per hour, which really does limit what his options are. So how do the processes used for parts A and B differ? How are the same? With part A, I just needed to worry about the hourly rates, right? But with part B, I had an extra little guy to take into account. I had to do a little bit of subtraction before I could worry about my hourly rates. But for both of them, we were looking at the hourly rates, right? We did have to take that into consideration. So what we're going to be doing this unit is solving equations and inequalities. We're going to just kick it off with solving linear equations, day 1. So again, we're lesson E.1-1A, our Envision unit, topic 1, lesson 1, and we're doing day 1. So you have this example in your book there on page 5. What is the value of x in the equation? 2 times x plus the quantity x plus 4 divided by 3 minus 8 equals 32. Now, there is more than one way to tackle this problem. So method 1, and again, there's a lot of different ways. I'm going to show you 2 different methods. There's a lot of different ways to do this. For method 1, what I'm going to do is I'm going to multiply everything by 3 first. I hate having that 3 in the denominator, really don't like it. So I'm just going to multiply each side by 3. So I'm going to multiply everything by 3. Let me get my pen out here. So I'm going to multiply this by 3. I'm going to multiply that by 3. I'm going to multiply that by 3. I'm going to multiply everything by 3 so that I can cancel out the fraction. So this is one method of approaching it so that I don't have the fraction anymore. I'm not dealing with fractions. I can just multiply everything by 3. So those will cancel out. I still have 2 times x plus 4, but now I have 3 times 8, which is 24, and 3 times 32, which is 96. And I did use a calculator. I won't deny I had a calculator handy for some of this stuff. And at this point, we can just solve it. There are a lot of different ways. Again, a lot of different ways to tackle this. I'm going to go ahead and distribute the 2. 2 times x is 2x. 2 times 4 is 8. I'm going to combine my like terms, right? A positive 8 and a negative 24 together gives me a negative 16. And at this point, you guys have done this a million times. I'll add 16 to both sides, right? So I get 112. And then, of course, I will divide both sides by 2. and I get that x is 56. Hooray. This is not the only way to do it. And maybe you're not comfortable with this. Maybe you're not comfortable with multiplying everything by 3 right at the start. That's cool. I get it. So maybe you'd like method 2 a little better. For method 2, what I did is I got rid of the -8 first. I went ahead and I added 8 to each side first. I felt like it was kind of dangling, kind of hanging out there. So I added 8 to each side just to make that go away. And just kind of simplified things a bit. So I still have 2 times the quantity x plus 4 all over 3, but now I have 32 plus 8. Now it's equal to 40. And at this point, yeah, I want to undo this division. We undo division with multiplication. So multiply both sides by 3. So I now have 2 times the quantity x plus 4 equals 120. And then I'll go ahead and I'll distribute. So I get 2, pardon me. Oh, actually, there was a different tactic here. Hang on. I'm going to show you the tactic that they used in the book. At this point, you could distribute, again, more than one way of doing this, or it looks like the book divided by 2, right? Make those 2's go away. So they have x plus 4 equals 60. And then, of course, we subtract 4 on both sides, and we get x equals 56. We got the same answer. This is just 2 different methods for solving this equation. And these aren't the only ways to solve it. There are other ways to solve this equation. As you saw, we could have distributed the 2, right? So many other ways of tackling this. So do what works for you. Do the method, do whichever method you are most comfortable with, but just be careful. And if you're careful, you should still get the same answer as everybody else. So now that we've played with this a little bit, I would like you to solve the equation 4 plus 3x minus 1 over 2 equals 9. And maybe even give a little explanation of the reasons why you chose your solution method. Why'd you go that way? Again, there's more than one way of doing this, so do the way that you're most comfortable with. Go ahead, hit pause, work this out, and then hit play when you're ready to check your work. So which method did I choose? You know what? I like to get rid of the dangly guy first. Again, you don't have to, but for me personally, I hate this little like plus 4 hanging on the end there. So I'm going to undo a positive 4 by subtracting it on both sides. So that will cancel out. And now I have 3x minus 1 over 2 equals 5 because 9 minus 4 is 5. And again, I don't like the dividing by 2. We undo division with multiplication. So I'll multiply both sides by 2. So those will cancel out. And I now have 3x minus 1 equals 10. I am going to go ahead and add 1 to both sides because that's what we have to do. And now I have 3x equals 11. Sorry about the lights in here. We know that's a problem around this place. And last but not least, I'm going to divide both sides by 3. Now, the only thing is it doesn't divide evenly. So I went ahead and left my answer as a fraction. So I chose, if you want to give a little explanation, I chose method 2 to solve this just because I don't like having the little thing dangling on the end. I don't like that. It's my personal feelings on this subject. If you chose to multiply everything by 2 first, you should have still ended up with the same answer. It's fine. Use the method that works for you. Either way, the answer is going to be x equals 11/3. So use the method you're comfortable with. That's okay. So now that we're getting back into the habit of solving equations, what you do to one side, you must do to the other. We use inverse operations, right? You undo division with multiplication, you undo addition with subtraction, so on and so forth. Let's take this to the next level. If you go over to page 6, you'll see example 2. And it says the sum of 3 consecutive integers is 132. So what are these 3 integers? So let me see if I can walk us through this. When they say consecutive integers, they just mean the numbers one right after the other, right? So if the first number was 3, the next number would be 4, the next number would be 5. So it's what they're talking about when they say consecutive integers, just boom, 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 one right after the other. So if that's the case, let me just give this some thought. I want to write an equation to model the problem and then solve it, right? So the three integers are consecutive. So that means that each is one greater than the previous number. So if the first integer, if there's three consecutive integers, if the first integer is x, well, then the next one will be one more than that, right? Because it's the very next number. So it'd be x plus 1. And that means the next number would be one more than that one. So the next number would be x plus 2. Okay. So I want the sum of my three consecutive integers. Sum means that we need to add all three of these together. And of course, it should equal 132. So great. If the first number is x, the next one will be x plus 1. The next one will be x plus 2. Awesome. Ooh, I have a whole bunch of like terms. We should combine our like terms because we have a whole bunch of those. So I have x plus x plus x, which will give us 3x. I also have a plus 1 and a plus 2, which will give us 3. Oh my gosh, and now this is easy to solve. So now that I've combined my like terms, this is so easy to work out, right? I'll just subtract 3 from both sides. In fact, here, I wrote it here. Let me erase these. I did write it down here. So I'm going to go ahead and subtract 3 from both sides, which will cancel these guys out. That's why we did it. So I now have 3x equals 129. And then let's go ahead and divide by 3 on both sides so that these will cancel out. We undo multiplication with division. And I totally used my calculator because I did not know that one off the top of my head. And I got x equals 43. Now hang on. We need to make sure we answer the question. The question says, what are the three integers? We only found the first one, right? The first of the three consecutive numbers is 43. So if the first one is 43, the next one will be 44, the next one will be 45. Yeah. So the three consecutive numbers whose sum is 132 are 43, 44, and 45. If you want to double check, you can add the three together and make sure they add up to 132. Just saying. I want you to try one of these. Read carefully because this next one's a little different, just a little different. Number 2, I'd like you to try it. The sum of three consecutive odd integers is 57. So what are the three integers? Go ahead, hit pause, see if you can work this out, take your time, and then hit play when you're ready to check your work. Okay, this one was a little different because it said consecutive, but it said that they were odd, right? So my first number would be x, I don't know it. But if I'm looking for the next, so the first number, it's going to be an odd number, which we'll call x. But if I want the next odd number, like if my first number were 3, the next odd number wouldn't be 4. 4 is not an odd number. My next odd number would be 5, right? So that means I'm not adding 1 this time. I need to add 2 to get the next odd integer. Because if I go 3, the next odd one would be 5. The next odd one would be 7. So I have to add 2 more to get the third odd integer. So if the first one is x, the next odd number would be x plus 2, and the next odd number would be x plus 4. So this one was a little different. And of course, sum means I'm going to add them all up, and it should equal 57. Of course, I'm going to combine my like terms. X plus x is 3x. 2 plus 4 is 6. And then I'm going to go ahead and subtract 6 from both sides so that those cancel out. And do a plus 6 with minus 6. So I have 3x equals 51. And of course, I will then divide both sides by 3. And I find out, sorry, I got crowded there. And I find out that x is 17. But of course, x being 17 is only the first one, right? If 17 is the first odd number, the next odd number, 2 more, would be 19. The next odd number, 2 more after that, would be 21. So the three consecutive odd integers whose sum is 57 are 17, 19, and 21. As always, guys, I hope you found this helpful and I hope you found this useful. If you've got questions, you've got concerns, feel free to come talk to me, email me, come see me at lunch, office hours, all that good stuff. You know I'll be around, and I'll see you guys later. Bye.